Today we're going to find local apparent noon. So local apparent noon is not always 1200. It's going to be a little bit before, a little bit after. For us, we have to go into the Nautical Almanac and go in there and actually find the time the sun reaches its peak. After that, we go out there with the Sextant, find our HS, convert that to HO, and then we're on the home stretch of getting our latitude by local apparent noon. To start, you need the Nautical Almanac, you need the strip form itself. The top of the strip form is asking for your DR latitude and longitude, so you DR out around the time of meridian transit and find a latitude and longitude. So for this example, we're using 3656.1 north, 075, 19.1 west on the 29th of May, 2026. So we'll open up to the daily pages for the Nautical Almanac for the 29th, and you'll see the daily page for it where you get GHA and declination of the sun. We'll use both of those. We use declination right this part of the strip form, and at the end, there's nothing on here that says GHA, but at the end I'm going to show you something with your GHA. There's another table in there that has meridian passage on it. That is the same thing as meridian transit. We're going to take that time for the 29th and apply it right here. For that, it was 11:57. Number 4 is asking for the difference between your longitude and your standard meridian. So for that, just take our longitude, 075 degrees, 19.1, and the closest meridian we have is 075. So you subtract it, 0.0. Find the difference, which is 0 degrees, 19.1 minutes. 19.1 minutes. I like to go ahead and convert that because we have to convert that to a whole degree to find our time later. You take your difference and divide that by 60, and you end up getting a 0.318 with running threes degrees. Number 5, it wants that in time. So all you have to do is take your degrees. For every 1 degree equals 4 minutes. We're going to take this and multiply it by 4. And we end up getting 1 minute. It was 1.27, so minus 1 times the 0.27 by 60, you get 16 seconds. So 0.31833 degrees times 4 equals 1 minute, 16 seconds. Number 6 is simply just taking that and we're going to add it together. We're going to use adding because between the 2 meridians that we used, just to draw it out for you, 075, 060, 090. Our meridian is over close to there. We use 075 to find the difference. We have to add to get to us. So this would be plus 11:57 plus 1 minute and 16 seconds is 11:58 and 16 seconds. Find his zone description, or we talked about this in a couple of videos before. All you're going to do is take your longitude, make it one number, divided by 15. In this case, it is plus 5. Now we do recognize daylight savings. Now you can do daylight savings for this if you are going out there with your watch, and your watch should be in whatever local time you're in. But for the sake of the strip form and the following thing we're going to go, leave it in the time zone we're supposed to be in. If we didn't recognize daylight savings, we would be in plus 5 Romeo. We're going to add that 5 to 11:58:16, making it 16:58, 16 seconds. Now we're done with that part, we're going into the sextant itself. So for this example, when I went out there with my sextant, I got 74 degrees, 30.6 minutes. So basically at the time of 11:58:16 or 16:58:16 if you're going off GMT, that is the time that I got my HS. That's the time of local apparent noon when the sun was at its peak. We're going to correct the sight. It was, for this example, it was 1.8 off the arc. If it was off, you have to add to take it back to 0. And our dip was 10 feet. For all the problems that I use on this channel, it's always 10 feet, but use whatever you're using. And if you go on the correction table, it gives you minus 3.1 minutes. Apply those to your HS. We end up getting an HA of 74 degrees, 29.3. Going to the altitude correction table, finding your HA inside the table and what number is right beside it. It was a plus 15.7 minutes. Add that to it to get our HO, 74 degrees, 45.0. All right, kind of breezed through that because with a lot of the sites that we've done on the previous videos, it's the same process to get your HO. Right here, it has 90 degrees already in there, but on the strip form, that makes the math a little easier. They write it as 89 degrees, 60 minutes. Same thing as 90. You're gonna write down your HO that we got on the step previous. And we're going to do 90 minus HO to find our whole altitude of HO. So basically 90 degrees, you have to think the sun is directly above you and you got the horizon. That's 90 degrees. You're going to subtract the HO to get whole altitude, which equals your zenith distance. We'll talk about that in a second. We end up getting 15 degrees, 15.0 minutes. Go into the Nautical Almanac on the same day of the 29th of May, 2026. Find your declination for the hours of 16. And we end up getting 21 degrees, 41.3. Now we have the scenarios. Try to illustrate it and make it a little bit easier to remember. So for this example, when we have a north latitude and a south declination, you do the 90 minus HO, which we did, to get your zenith distance, and you're going to subtract your declination to get latitude. For our example, this scenario would be it. We have a north latitude and a north declination, meaning they're both north of the equator. We're going to add them together. So zenith distance minus declination gives you latitude. And then we have the third scenario. When you have north latitude and north declination, but your declination is more than your latitude, you're going to do declination minus zenith distance. You're going to reverse it to get your latitude. And you mostly see this if you're closer to the equator. But this is the example this is a scenario for our example. We're going to add them together. So 15 degrees, 15.0 plus 21 degrees, 41.3. We end up getting 36 degrees, 56.3 north. Compare that to our DR latitude longitude, and I would say we're spot on. 0.2 ain't nothing if you're in the middle of the ocean. Now I said something earlier about GHA. Since the sun will be straight above you based off Greenwich, that's what GHA is based off of, your GHA should equal your longitude. So basically all you're going to do is take 16:58 and 16 seconds, go to the increments and corrections page, use the daily page as well. So daily page for 16 hours on the 29th, we end up getting 60 degrees, 38.5 minutes. Now we go to the back of the book for the anchorage and corrections page, find the table for 58 minutes, and scroll down until we hit 16 seconds. And GHA is always plus degrees, 34.0 seconds. Add them together, and we get 075 degrees, 12.5. Compare that to our DR longitude. We're a little bit west of where we thought we were, but you can always update it later, adding sunlines to this. And this you can use as a sunline. It'll be a straight line through your local, your universal plotting sheet. And if you were to put it in Stella, it will also show it as a sunline. And you can use this to advance to your next sunline for a running fix, and so on. If you enjoyed this content, hit the subscribe button, hit the like button, and see you on the next one on the chart table.